Hey there, Ryan Reynolds here. It's a new year, and you know what that means. No, not the diet. Resolutions. A way for us all to try and do a little bit better than we did last year. And my resolution, unlike big wireless, is to not be a raging and raise the price of wireless on you every chance I get. Give it a try at mintmobile.com/switch.
$45 upfront payment required, equivalent to $15 per month. New customers on first 3-month plan only. Taxes and fees extra. Speed slower above 40 gigabytes on unlimited. See mintmobile.com for details.
Taxes was feeling so stuck. Sitting in traffic, squeezing into a parking spot, all to squeeze in getting tax help during your lunch break. Now Taxes is a TurboTax expert who does your taxes for you, while you go about your day getting real-time notifications about their progress and the most money back guaranteed. Now this is Taxes. Intuit TurboTax. Get an expert now on TurboTax.com. Only available with TurboTax Live Full Service. Real-time updates only in iOS mobile apps. See guarantee details at TurboTax.com/guarantees.
This is SpaceTime Series 28, Episode 9, for broadcast on the 20th of January 2025. Coming up on SpaceTime, Starship destroyed in a spectacular explosion during its 7th test flight. A mostly successful maiden flight for Blue Origin's New Glenn mega rocket. And uncovering the source of mysterious stellar pulsations from deep space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
There's been a spectacular ending to SpaceX's 7th Starship test flight, with the Starship upper stage exploding in a fiery blast as it was ascending to orbit. But the mission wasn't without its successes either, with the Super Heavy booster being successfully caught by the launch tower's chopstick arms during an amazing textbook landing. The 124-metre tall mega rocket had blasted off from SpaceX's starbase at Boca Chica on the Texas Gulf of Mexico coast on a flight that should have taken it to a splashdown 66 minutes later in the Indian Ocean off the Western Australian coast.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. Vehicle's pitching downrange. Booster check pressure's nominal.
All right, we're more than 30 seconds into flight. Telemetry showing 33 out of 33 engines as it's pitching downrange.
Booster, chip, avionics, power, and telemetry nominal.
Hearing good call-outs on the ship and booster avionics. You just heard the rumble hitting us about 6 miles away. Watching Starship arc into just endless blue skies right now.
Vehicle supersonic.
More than a minute into flight, the vehicle's supersonic.
Max Q.
So we just passed through max Q. That's the greatest stress the vehicle's going to experience on the way uphill. Reminder that all of our teams down here on the ground are now looking at systems on the tower. They just did a manual check through. That's going to inform that manual flight director's decision. Next moment coming up, though, is going to be hot staging.
What a gorgeous ascent.
6 ship engines getting ready to ignite. That's going to happen while we're still attached. We are hearing good call-outs on the tower preparedness from the manual checks. Though we've still got automated checkouts on the booster and the ship itself. But as of right now, our manual checks and our manual commanding is looking go for a catch.
Booster engine cut off. Engine startup.
Most engines cut off, down to those middle 3.
Booster burn startup.
All right, hot stage confirmed. We've got a booster hopefully on its way back to us, and a ship now making its ascent burn into space.
The booster is now making its way back down to Earth. Looks like we have 12 of those 13 engines ignited. We're using the engines that actually gimbal.
We are go for booster return.
An excellent call out there. We are go for booster return.
Avionics, power, and telemetry nominal.
There's a lot of criteria that needed to line up to ensure that we could have a safe booster catch, and it sounds like we got the go for that. We just jettisoned the hot stage floating away from the Super Heavy booster. Now we've shut down the engines for that boost back burn. That confirms boost back burn is now complete. That was the first of 2 burns required for the vehicle to make its way back down to Earth.
7 minutes after launch, the the first of the test flight goals was achieved with a 33-engine Super Heavy booster undertaking a pinpoint landing in the Mechazilla-like arms of the launch tower.
And next coming up will be the landing burn. That's going to be 13 of those center engines igniting again. That will then go down to, from 13 down to 3 engines just right before we touch down for that booster catch. Now, reminder, our stage 1 objectives are to have a controlled ascent, stage separation, as well as a controlled boost back burn and hot stage as well. So we're looking good for that so far. Now, Starship is still firing its engines right now.
Starship trajectory nominal.
Again, the booster is currently making its way back to the tower today. So we're looking forward to a booster catch with the chopsticks. And in the meantime, those grid fins helping to control the vehicle and guide it back to its landing site.
Booster FTS is saved.
We can see the booster coming back in now through the plume. At least it looks that way to us. It's incredible that it basically returns. It looks like a speeding, just like this silver flare, attempting to catch the booster at the tower. This would be the second tower catch.
Booster
landing burn, seeing 13 engines.
Booster now hovering as it aligns with the tower for catch.
Booster coming in. Get ready for that boom.
Down to 3 engines.
Mechazilla has caught the booster.
Once again, for the second time, a successful catch by the launch tower. This is the same tower, the launch pad, where that booster took off from just 7.5 minutes ago.
But just a minute later, mission managers suddenly lost contact with the 52-metre tall Starship upper stage. All 6 of Starship's Raptor engines had been firing as planned during the ascent burn, but high over the Caribbean, just as Starship was getting to the end of its climb to orbit, telemetry suddenly began dropping out on the engines and all contact was lost with the spacecraft.
Waiting for an update on what our ship status is. We were approaching that ship engine cutoff time, so just waiting to hear. So obviously we've got booster back, booster on the launch tower in the chopstick arms, but we are waiting to get an update now on the ship. As we were expecting ship engine cutoff about 40 seconds ago. We saw some of those engines start to go out prior to that point. And so right now we are just standing by to try and get the latest word on where we are with ship. So stick with us for just a couple of minutes as we wait to hear some updates.
Obviously, from the last 2 flights that we have done, where the Flight 6 we attempted but had to divert into the ocean, and then on Flight 5 we did have the first ever successful catch of the booster. We used the learnings of those 2 flights to hone in that catch commit criteria, and we saw success today, which is pretty awesome.
Yeah. And just a quick status check. So we currently do not have comms with the ship. So trying to figure out exactly when that happened and exactly what happened. So obviously the flight controllers right now going through their data, looking to make sure it's not anything instrumentation on the ship, but actually try and get us a status. So if you are just tuning in, we caught a booster. But we are still waiting to find out a little bit more on the ship. So it had successfully separated. We did that hot staging maneuver. We did see all 6 of ship's engines on the way uphill during its ascent. But as we were getting to the end of that ascent burn, we saw engines dropping out on telemetry, and we have since lost contact with the ship.
Moments later, burning debris was seen streaking across the skies. Flight 7 used a new updated version of Starship, about 2 metres longer and fitted with a range of upgrades and new modifications. These included newly designed forward flaps, which were reduced in size and moved further forward towards the vehicle's nose and away from the heat shield. Now, this both significantly reduces their exposure to re-entry heating and simplifies the underlying mechanisms and protective tiling. But more importantly, there are also redesigns for the propulsion system of this new upper stage, including a 25% increase in the propellant volume, the vacuum jacketing of feed lines, a new fuel feed line system, and an improved propulsion avionics module controlling valves and reading sensors. Now, all this should have improved the vehicle's performance and its ability to fly longer missions. About 17.5 minutes after liftoff, the upper stage was to deploy 10 dummy satellites, similar in size and mass to SpaceX's Starlink broadband internet satellites. However, the mission never got that far, as debris came raining down over the Caribbean Sea. SpaceX boss Elon Musk says preliminary indications suggest an oxygen fuel leak in the cavity above the spaceship's engine firewall, and that was large enough to build up pressure in excess of vent capacity. Musk says apart from the obvious double-checking for leaks, SpaceX will now add fire suppression to that cavity and probably increase the vent area. He points out that the ship's new forward flaps, higher thrust engines and tile adherence on ascent were all tested. In fact, improved heat shield performance was the only major thing that wasn't tested, along with the PEZ payload dispenser. And these will probably be resolved in next month's launch. He says nothing so far suggests pushing the next launch past next month. And it doesn't change the likely date at which Mars will become self-sufficient, a clear hint at the long-term aim of the Starship program, which is to act as an interplanetary transport and colonization vessel. The 250-ton reusable mega rocket is the largest and most powerful spacecraft ever built. It's capable of lifting 150 tons of people and cargo into orbit and 100 tons on missions to the Moon, Mars and other planets across the solar system. Starship's first mission for NASA will be to dock with the Orion capsule in translunar orbit and carry the Artemis 3 mission astronauts down to the lunar surface in 2026. It'll then provide regular shuttle services for NASA between the new Gateway space station, which is yet to be placed in orbit, and the lunar surface. SpaceX plans on eventually using Starship to replace the company's existing Dragon spacecraft and its Falcon 9 and Falcon Heavy launch systems. Both manned and freight-only versions of Starship are planned, as well as refueling tanker versions. And SpaceX is also looking at using Starship to provide point-to-point transport for passengers between major cities on Earth. Remember, once you're in orbit, any two places on the planet are only ever 90 minutes apart. This is SpaceTime. Still to come, the maiden flight of Blue Origin's New Glenn mega rocket and uncovering the source of mysterious stellar pulsations from deep space. All that and more still to come on SpaceTime. Well, we've seen 7 test flights, some more successful than others, of SpaceX's Starship Super Heavy, and we've seen a successful first flight for NASA's SLS, Space Launch System, which will take the Orion capsule and Artemis spacecraft on missions to the Moon and eventually Mars and beyond. And now the third of America's trio of new mega rockets, Blue Origin's New Glenn, has successfully undertaken its maiden flight. The NG-1 mission, which had been delayed several days, successfully launched from Space Complex 36 at the Cape Canaveral Space Force Base in Florida. High seas at the booster landing site and a buildup of ice on a purge line were blamed for the delays. The flight successfully placed the upper stage and payload into its pre-planned orbit.
T-minus 10, 9, 8, 7, 6, 5, 4... Liftoff. All 7 engines at full thrust. Chamber pressures are good. Vehicles cleared the tower. Engine chamber pressures look good. Now begun the pitch roll maneuver to point downrange. Body rate responses are nominal. Chamber pressures continue to look good. Now 40 seconds into flight. End of roll. Strakes are now level. Data quality looks good coming down from the vehicle. Passing Mach 1. New Glenn is now supersonic. Engines continue to perform well. Now passing through max Q. Maximum dynamic pressure. Body rate responses are nominal throughout the boost phase. Chamber pressures continue to look good on all 7 B4 engines. Acceleration profile is good. Body rates look good. B3U LH2 chill-in started. B4s continue to perform well throughout the boost phase. Stage 2 RCS priming. And we have MECO. We have stage set. And we have ignition on both B3Us. Chamber pressure is good. Now passing 3 minutes, 40 seconds into flight. Body rates look good. Data quality coming down from both stages looks good. GS2 performing a pitch-up maneuver. Body rate response is nominal. B3U chamber pressure continues to look good. We have good payload fairing jettison.
Our booster is going to try to make a landing. We're going to land on the Jacqueline, the landing ship that is awaiting this beautiful booster to make a landing.
Trajectory looks good on both stages.
Stage 1, our booster. We are looking to land it on our landing ship Jacqueline. Stage 2, carrying the Pathfinder for Blue Ring, will continue its mission up towards MEO orbit, where we will be collecting data for 6 hours.
Confirmed GS1 engine chill active. Less than 1 minute now remaining to exo-atmospheric engine ignition.
So coming up here, we're going to see the middle of the 3 7BE4 engines on the booster light up.
Good. Chamber pressures on both VE3Us.
This is going to slow the vehicle down, and then as the vehicle gets closer to the landing ship, the Jacqueline, the 2 outer of the 3 middle engines will shut off, and just 1 in the center will remain to help slow as well as guide the vehicle back to the landing ship. We have the steering fins at the top of the booster, as well as the strakes, which act essentially as wings. This vehicle is flying back to the Jacqueline, providing lift to come in for a nice, soft, and vertical landing onto the landing ship, the Jacqueline. All 3 engines relight confirmed.
8 minutes, 20 seconds into flight. GS2 tank pressures staying within their acceptable limits. Body rate responses look good. Chamber pressures look good throughout the burn. Continue to see data from both stages.
Our second stage, GS2, continues
10 minutes, 20 seconds into
its
flight.
ascent, as well as its climb towards MEO, which is where it is headed this evening.
GS2 is now 1,700 kilometers downrange, traveling at 6.7 kilometers per second. We have IAP vanish. GS2 is now orbital, and we have engine cut off.
However, the attempt to land the first stage booster on a pre-positioned barge 1,000 kilometers downrange in the North Atlantic Ocean failed.
We obviously have some frozen data here on our stage 1, on our booster. We're still waiting to understand what the situation is with the booster. We're trying to get all of the data here. We seem to have lost telemetry on the first stage. We very well may have lost the booster. And now I do have confirmation that we did in fact lose the booster. As you did hear, we did have the booster relight the 3 middle engines, which is what we were looking for. So things we know were good up until that point.
The first stage telemetry showed the booster was travelling at an approximate speed of Mach 5.5 and at an altitude of 25.7 kilometres before it suddenly disappeared, deemed lost. But the mission's payload, which made it successfully to orbit, was a prototype for Blue Origin's new Blue Ring orbital vehicle, a manoeuvrable spacecraft designed to dock with and service satellites. The 98-metre-tall 2-stage rocket's named New Glenn in honour of Mercury 7 astronaut John Glenn, who was the first American to orbit the Earth. Its smaller cousin, New Shepard, which is used to carry space tourists on suborbital joy flights beyond the Kármán line, the internationally recognised start of space, is named after another Mercury 7 astronaut, Alan Shepard. He was the first American to achieve spaceflight. But whereas New Shepard's a fairly small single-stage vehicle with a capsule mounted on top, New Glenn is a massive rocket, capable of carrying 45 tonnes into low Earth orbit, more than 13 tonnes into geostationary orbit, and at least 7 tonnes into translunar orbit. NASA's already contracted New Shepard to carry 2 Mars probes to the Red Planet, and it will also support the deployment of the new Kuiper Internet satellite constellation, which will ultimately compete against Starlink. This is SpaceTime. Still to come, uncovering the source of mysterious stellar pulsations from deep space. And later in the science report, a new study shows that New Zealand's ancient bird, the moa, had what today would be considered very expensive tastes. Apparently, they liked eating truffles. All that and more still to come on SpaceTime. Astronomers have discovered the source of a mysterious extreme astrophysical event known as a long-period radio transient, a strange, regular pulse of energy being emitted from somewhere in deep space. The findings, reported in the astrophysical journal Letters, point to a system made up of a highly compact stellar corpse known as a white dwarf, the superhot core of a once sun-like star, and a low-mass spectral type M red dwarf star, the most common type of star in the galaxy. Researchers made the discovery after first detecting a pulse of bright energy coming from deep space among archival low-frequency data from the Murchison Wide Field Array Radio Telescope in outback Western Australia. The array is one of the precursors for the Square Kilometre Array project, which is currently under construction and, when completed, will be the world's largest radio telescope. So big it's being built across 2 continents, the outback of Western Australia and Southern Africa. The strange energy pulse of radio waves known as long-period radio transients were observed occurring every 3 hours and lasting around 30 to 60 seconds each time. And that makes these the longest period radio transients ever detected. Long-period radio transients are relatively new to science. Their source and how they're generated has been a long-standing ongoing mystery. But now, with this new discovery, scientists believe that they may have both identified the probable source of the energy burst and also shed light on how they're being generated. See, the problem is all previously discovered radio transients were located deep within the Milky Way galaxy and surrounded by lots of stars and gas and dust. And all that made it challenging to try and determine exactly what could have been generating these radio waves. One of the study's authors, Associate Professor Natasha Hurley-Walker from the Curtin University node of the International Centre for Radio Astronomy Research, says long-period radio transients are extremely exciting, but for astronomers to understand what they are, they need an optical image. And the problem was, when you look towards the source of the signal, there are simply too many stars in the way. But in a stroke of good fortune, the newly discovered transient, named Glean XJ070437, was found on the outskirts of the galaxy, in a much more sparsely populated region of space, in the constellation Puppis, around 5,000 light-years away. Because the new discovery lies far off the galactic plane, there are only a handful of stars nearby. And Hurley-Walker and colleagues were able to narrow down the source generating the radio waves to one specific star system. Then, using another square kilometre array precursor, this time the Meerkat telescope in South Africa, they were able to pinpoint the location of one specific star. Following up with the SWORD telescope in Chile, they determined the star's spectra, showing it to be a low-mass spectral type M red dwarf. Now, this discovery answered some pressing questions, but it created a few more. An M dwarf alone simply couldn't generate the amount of energy that the astronomers were seeing. Remember, these are very low-mass stars. They only have a fraction of the Sun's mass and luminosity. And as we mentioned earlier, there are lots of them, making up some 70% of all stars in the Milky Way galaxy. But as the authors looked further into the data, they found that this specific red dwarf was actually part of a binary system with another object, most likely the corpse of a dead Sun-like star known as a white dwarf. And together, the two of them power the radio emission. The authors are now working on follow-up observations that will conclusively determine the nature of the system and also the explanation for this extreme astrophysical event.
Long-period radio transients are a mysterious new class of repeating radio source in space. You might be familiar with the idea of a pulsar. That's a rapidly rotating neutron star that produces a continuous beam of radio waves, and the radio waves can be offset from the axis of spin. So a little bit like a lighthouse, the pulsar can spin around, and every so often the radio waves go across our line of sight and we see a pulse. And that's why pulsars are called pulsars. So we have long known that pulsars spin every few milliseconds, every second, something along that line, maybe up to once every 10 seconds. But we've always thought that as the pulsars slow down, their radio emission stops. And so we've never seen pulsars that are longer, like slower period, than about 30 seconds. So in a way, we've kind of stopped looking for things that spin more slowly than that. And that's led to a kind of a bias in our observations where we're only looking for quickly spinning things. Now, my team, about 4 years ago now, we did a blind experiment where we looked for things that change in our galaxy and across slower timescales, like if they could change minute to minute or week to week, we would pick them up. And we found one source that in 2018 appeared and disappeared every 18 minutes, which is much, much, much slower than a normal pulsar. And indeed, you would not have been able to find this object with a normal pulsar search. So that was a real mystery. And that source basically produced pulses that lasted 1 minute each, and they were 18 minutes apart. And it was only on for 3 months in 2018. And by the time we found it in 2020, we had missed the fireworks, essentially. We didn't know what that source was, and we couldn't really go and get more observations. We tried, but it had switched off. So then I designed a new survey to actually find these things and very quickly follow them up. And we found a new source which repeated every 22 minutes, which is still completely inexplicable. We have no idea how you generate radio waves that repeat every 22 minutes. And we rapidly followed that up with lots of telescopes, and to our surprise we also found that in other archives that went back even longer than the MWA, there were actually pulses all the way back to 1988, and that was GPM J1839-10, and that repeated every 22 minutes and has been active for 33 years. So that was a mystery because we thought that these things would only be briefly active and then disappear. Now we have one that's been here all this time. But the other thing that tells us is that there must be lots of these hiding in our data. data, because if astronomers could miss something sitting right in front of them for 33 years, then all of our data must be full of these objects.
That's just what science is about a lot of the time. Blue sky surveys, just looking, what about this? What about that?
Exactly. There was no theory that predicted this. In fact, quite the opposite. We had theories that said there will absolutely not be any radio waves that appear on timescales of more than 10 seconds or more. So it was really a huge leap forward to find these sources. Now, when you say blue sky research, the issue that we have with these long period radio transients is that it's kind of white sky research. So we're embedded in our own Milky Way galaxy, and so are these long period radio transients. And when you think, where is all the stuff in our galaxy? Where are all the stars? Where are all the neutron stars? Where are all of the black holes? Where is everything? Well, it's all clustered together in the disk of our galaxy. You go outside on a dark night and you can see the Milky Way laid out overhead. Well, kind of unsurprisingly, that's where we're finding the long period radio transients, because they're in our galaxy. The difficulty is that then when we want to ask the question, okay, what can generate radio waves every 20 minutes? What's actually producing this? It's a really hard question to answer, because if you look at where the radio pulses are coming from, there are thousands of stars. There's no way of telling which star, if any, of course, it could be some kind of invisible object like a neutron star or a black hole or a white dwarf. You can't tell which one is producing it. And then that means it's very hard to say how the radio emission is generated and, what these things actually are.
But then you had a bit of luck.
Well, fortune favors the prepared mind, right? So we realized that this was a problem. And while we had been doing surveys that are targeting the galaxy with the hope of finding these things, once we realized, well, okay, great, we can find them, but it doesn't help too much if we just find some radio waves and we can't follow them up. We need to look at the rest of the sky. And so very fortunately, I'm the lead scientist on the galactic and extragalactic all-sky MWA Extended Survey, or GLEAM-X for short, which is a successor to the very popular GLEAM survey, which was the first survey in radio color. And GLEAM-X is surveying the whole sky south of declination 30, so that's about 75% of the visible sky. And in doing that, of course, we cover parts of the sky that are our own galaxy, but also lots of parts that are kind of looking slightly away from where all of the stuff is. And in searching that data, we optimized our algorithms to find the long period radio transients. And I worked with a wonderful third-year undergraduate student called Chanad Horvath, who helped implement filters that would be better at picking these elusive signals out of the data. And we were successful.
And you saw this red dwarf.
So that's right. So we found a repeating radio transient that isn't buried deep inside the galaxy. It appears about 13 degrees off the plane. So it's still in our galaxy. It's just not buried inside all the mess of all of the stars. And we could see with the accuracy of the MWA that the radio pulsations were coming from one of two different stars. We weren't sure which one. Or indeed, it could have been that it could have been appearing from an invisible source between the stars. We weren't really sure with the accuracy of the MWA, but we were able to make the detection. So we followed up with Meerkat, which is another big telescope in the Southern Hemisphere, and indeed both the MWA and Meerkat are precursors to the Square Kilometre Array. So Meerkat's in South Africa, and I have a great working relationship with the team there. They've done lots of fantastic observations towards these long-period radio transients. So we got time to look at our source, and Meerkat has a better positional precision, and boom, highlighted that those pulsations were coming from one specific star, an M3 dwarf. So it seemed very difficult to explain that we're seeing these bright radio pulsations from what looks like kind of a boring star. But when we looked at the timing of the pulsations, sometimes they would arrive a little bit sooner than they expected, and sometimes they would arrive a little bit later than we expected, as if the source of the radio waves was moving closer to us and then further away, and then closer and then further away. And that, of course, implies an orbit. So as if the radio emitter is in an orbit with the M dwarf. Now that's exciting because there are actually known systems that behave this way, and while some of them have produced radio waves, none of them have ever been as bright as the long period radio transients. It at least gives us some kind of framework to start testing our observations and testing what we see against that theoretical model.
Now, at this stage, the hypothesis is that the binary partner to this red dwarf, it's not likely to be a neutron star because the beam isn't powerful enough, but it could be a white dwarf.
Yeah, that's the suspicion. Now, unfortunately, our system, while it is out of the plane, is 5,000 light years away. So it's still really, really far away. Now, a white dwarf, to put it into context, a white dwarf is this core of carbon and oxygen and helium, and it's quite small. It's about the size of the planet Earth, and it's quite bright in UV, so like just a little bit shorter wavelength than the visible light that we see. But they're so small, they're quite dim, and the blue light that they produce is very easily absorbed by dust in our galaxy. And so even though our source is quite off the plane and it's closer than most of the long-period radio transients, it's still really, really hard to tell. So we are working on follow-up with other telescopes to try and pick out whether there is a white dwarf in that system. And that would really be smoking gun evidence that at least some of the long-period radio transients are caused by these binary M-dwarf, white dwarf systems. And that's very cool because white dwarfs, they're not supposed to act like pulsars, essentially. That would imply that the white dwarf has a very strong magnetic field. How did it get that magnetic field? Why is it using that magnetic field to generate radio emission? I mean, I had a lovely conversation with some white dwarf and M-dwarf experts a couple of weeks ago on a telecom, and we spent 2 hours talking about M-dwarfs and white dwarfs, and we were still not that much closer to explaining exactly how these systems work. But at least having an optical counterpart gives us something to follow up, as opposed to, well, it could be any of 1,000 stars nearby, and we have no idea where to start.
When we look at a planet like Jupiter, we know that a lot of its auroral activity comes not just from the solar wind, but also from one of its Galilean moons, Io, which is constantly spewing material into space. Could the red dwarf be doing the same sort of thing to the white dwarf?
I do agree. That is a very plausible emission mechanism. I believe that's called electron cyclotron maser emission. And there was actually a paper, literally, we put our paper on archive to say we had submitted it to Astrophysical Journal Letters. And within a week, a pair of theorists who work on these kinds of things had looked at our paper and another one that was published by or has been submitted by another group and did some very complicated math and said, okay, maybe it's electron cyclotron maser emission with relativistic electrons. Now, that's great. That's a step forward. Now we need to take some of the testable predictions from that paper and then compare them to our observations. And a lot of science is done like this. The observers will find something unusual or strange that is not explained by the current theories, and once we make enough noise about it and we say, no, look, guys, you've got to update your theories, the theorists will spend some time on a blackboard or a whiteboard, and then they'll write a whole paper of very complicated equations, which hopefully has some ideas in there about what observers should see if that theory is correct. And so we do this kind of dance back and forth.
That's Associate Professor Natasha Hurley-Walker from the Curtin University node of the International Centre for Radio Astronomy Research. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has warned that shallow groundwater is projected to warm on average by between 2.1 and 3.5 degrees Celsius by the end of the century. The findings, reported in the journal Nature Geoscience, are based on a new global groundwater computer simulation temperature model. The model estimates that by 2099, between 59 and 588 million people worldwide will be living in areas where groundwater exceeds the highest threshold for drinking water temperature. The model predicts the highest warming rates will be in central Russia, northern China, and parts of North America and the Amazon forest, with Australian groundwater temperatures also expected to rise. A new study has shown that sugary drinks could be responsible for 1 in 10 new type 2 diabetes cases and at least 1 in 30 new cases of heart disease worldwide. The findings, reported in the journal Nature Medicine, used worldwide data on the consumption of sugar-sweetened beverages, combined with data on diabetes and heart disease rates around the world, to estimate how many of these health conditions could reasonably be attributed to the negative health impacts of drinking too many sugary drinks. They estimate that in 2020, 2.2 million new cases of type 2 diabetes and 1.2 million new cases of heart disease could be attributable to these drinks, with sub-Saharan Africa seeing the greatest increase over the past 30 years. Scientists have discovered that the now long extinct ancient New Zealand bird, the moa, had expensive tastes, enjoying a snack on truffles. Scientists have found that fossilised moa droppings show that these ancient birds used to consume fungi that were symbiotic with trees. A report in the journal Biology Letters analysed 2 ancient coprolites found in Nelson and Fiordland beech forests, both from small upland moa, and identified fungal DNA and spores. They found that the moa had been munching on truffle-like fungi that have mutual relationships with forest-forming trees. The authors say that these native fungi may have been dependent on moa to spread their spores, so the extinction of these ancient birds that ate them could have affected not only their spread, but also native New Zealand forest ecosystems. Well, it was the biggest story in America just weeks ago, but all the hype about those so-called mysterious drones that were allegedly invading the skies of New Jersey have all of a sudden disappeared from the headlines. Or was it just that the real news of the disastrous LA wildfires took away all their attention? Tim Mendham from Australian Skeptics says the drone story was never a real story, just a lot of clickbait gone wild.
These things go in fads. They'll always come around, particularly UFO sightings and people like UFO hysteria and UFO enthusiasms. But the problem is that these things pop up every so often. We had the one not that long ago of the talks to Congress, etc., the witnesses coming before the US Congress and suggesting government knows about all these UFOs. They have them and they have the bodies and these things are buried under the ground, blah, blah, blah. And the truth will be out there within 12 months or whatever, and then it's never happened. They've been saying this since the 1940s when the UFO sort of craze first started, that the truth will come out very soon. We're waiting, 80 years later or something like that, and it still hasn't come out. These lights over New Jersey, it's fascinating stuff. People's looking up in the sky and seeing things they don't look up in the sky often enough, and they're seeing things up there which they can't explain. Fair enough. They're not trained observers in these things, and funny enough, these lights move exactly like planes move.
They even have navigation markings on them.
Some of them have navigation lights, and people ask, why would an alien craft have navigation lights? And someone suggested, it's insurance issues. The UFO's worried about bumping into another plane and they're being have to pay the insurance.
Those rats would be out of this world.
Yeah, but there's a lot of people who are sort of explaining patiently what these things are.
What self-respecting alien life form that's travelled billions of light years to reach us would fly over New Jersey?
Well, the same ones that fly over the Midwest of USA and kidnap local farmers, etc. And
give them a good probing.
So, surely one of them's going to land somewhere and reveal itself on the front lawn of
but what are you going to say?
The White House.
You're going to land on the front lawn of the White House and say, take us to your leader? There's going to be a lot of head scratching if that happens right now.
Very funny. After all these years, there is no evidence. And these New Jersey, everyone's calling them drones because they assume a lot of them are drones.
Some of them weren't drones. Some of them were actually aircraft.
That's right. Some of them weren't aircraft.
They were aircraft.
Anyone can look at them and see they're aircraft.
Some of them are drones. Amazon do parcel deliveries.
And drones are very common these days. You can pick them up at a local supermarket, basically. But, Uri Geller, of course, our favourite spoonbender and self-publicist, says these sightings are a warning to Earth with a show of power and superior technology, but Uri Geller will hop on.
Of course he does.
Of course he does. He will hop on any latest trend and sort of claim it. Yeah, these things, they come and they go. As you say, the Los Angeles fires have taken the New Jersey aliens totally off the front pages, but give it a few months, a year, perhaps a year and a half, and there'll be a new set of sightings and definite things which the truth is just around the corner. It's a regular occurrence. These things, it's a trend. They come and they go like all sorts of trends.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.